Hello, everyone. Welcome to Brain Blitz Audios. Today, in this episode of Cbse Board Exam, we'll be dealing with previous year questions of mathematics in Cbse board exams. And today, we'll be looking at questions of the first chapter in your grade 12 syllabus for Cbse. The chapter is Relations and Functions. Let's look at our first question. Let R be the equivalence relation in the set A is equal to 0, 1, 2, 3, 4, 5, given by R is equal to A comma B, such that 2 divides A minus B. Write the equivalence class for the element 0. Let's look at our question. So we have R is an equivalence relation, and our value for A is 0, 1, 2, 3, 4, 5. And the relation by itself is A comma B such that 2 divides A minus B. And we are asked to find the equivalence class of the element 0. So what that means is that in the elements A and B, the element A has to be 0, and we have to find the values for B. So in set A, which has 0, 1, 2, 3, 4, and 5, the elements 2 and 4 satisfy this relation. Because when we take 0, 2 and 0, 4, A minus B is divided by 2, divisible by 2. So that means this is even. So 0 minus 2, which is minus 2, that is divisible by 2. Minus 2 by 2 is minus 1. 0 minus 4, that is minus 4, that is divisible by 2. So minus 4 by 2 gives minus 2. So 2 and 4, they satisfy the relation. Therefore, the equivalence class of the element 0 will be 2 and 4. So 2, 4 is the equivalence class of the element 0 in the set A, which follows the relation R is equal to A comma B such that 2 divides A minus B. So that is our first question. Let's look at our next question. If R is the relation A comma A cube such that A is a prime number less than 5, be a relation, we're asked to find the range of the relation R. So R is equal to A comma A cube, and the domain consists of prime numbers less than 5. So the value of A should be less than 5, and A is prime. So think of prime numbers that are less than 5. The first prime number is 2, the second is 3, and the third is 5. So as you can see, 2 and 3 are less than 5. So our domain is 2, 3. Now, let's put the values of A is equal to 2 and A is equal to 3. So when A is equal to 2, the relation will be A comma A cube. So that will be 2 comma 2 cube, which is equal to 2 comma 8. So 8 is one of the values of the range. When A is equal to 3, the relation R is a comma a cube, so that is 3 comma 3 cube. So therefore that will be 3 and 27. So as you can see, 27 is another element that is present in the range of R. So the range of R will be closed interval 8 and 27. So these are the values of the range of R. And note that the range of R refers to the value of a cube. So over here you can see 2 cube is 8 and 3 cube is 27. Next question. State the reason for the relation R in the set 1, 2, 3 given by R equals 1, 2, 2, 1 not to be transitive. So the function here, we need to prove that it is not transitive. Prove that it isn't transitive. But what is a transitive relation? So a relation is said to be transitive if A comma B belongs to R and B comma C belongs to R, implies that A comma C belongs to R. So we have 3 elements A, B, C, and when we find that 2 of the elements are present in the relation as an element and another 2 are present as a relation. So we see that A and B here belongs to the relation R. So AB is from the set of the relation. And we find that B and C are also present as an element in the relation R. So since AB is belonging to R and BC is belonging to R, a transitive relation will have A and C belonging to R. First and second belongs to R, second and third belongs to R, implies that first and third belongs to R. So in our case here, 1, 2 belongs to R. Let 1 be A and 2 be B. And 2, 1 belongs to R. So let 2 be B and 1 be C. But the element 1, 1 does not belong to the relation R. If you can see, the relation is just 1, 2 and 2, 1. There is no 1, 1 in the relation. So that means 1, 2 belongs to R and 2, 1 belongs to R does not imply that 1, 1 belongs to R. Therefore, R is not transitive, hence proved. Our next question. If the function f of x is given as 27x cubed and the function g of x is given as x raised to 1 by 3, which is essentially cube root of x, then we have to find g of f of x. So what is g of f of x? So g of f of x is the same as this. So we have an element x, we perform a function f with respect to x, and then we get a value, and that value we use in another function that is g. So that is known as g of f of x. So g of f of x, let's put in the value of f of x. So that is g of 27x cubed. And since g of x is equal to x raised to 1 by 3, that implies that g of f of x will be equal to 27x cubed, the whole raised to 1 by 3. Now over here, we know that a raised to n times b raised to n will be equal to a into b whole raised to n. This is one of the laws of the exponents. So that means that here both 27 and x cubed have the same power 1 by 3. So we can split them as 27 raised to 1 by 3 times x cubed raised to 1 by 3. So now we know that 3 cubed, which is equal to 3 into 3 into 3, which is equal to 9 into 3, because we already know that 3 squared is 9, which is equal to 27. So 3 cubed is 27. So 27 cube root of 27 will be equal to 3 times cube root of x cubed is the same as x. So the 3 and 1 by 3 gets cancelled. So we get x. So our final answer for g of f of x will be equal to 3x. So if f of x is 27x cubed and gx is x raised to 1 by 3, then g of f of x will be equal to 3x. Our next question. If f is a function from real numbers, so f is from R to R, and it is defined as f of x is equal to 3x plus 5 by 2. And this function is invertible. Then we are asked to find f inverse of x. So the function has its domain and range as the set of real numbers. R is set of real numbers. So in order to do this question, we'll assume y to be equal to f of x. So y will be equal to 3x plus 5 by 2, which implies that 2y will be equal to 3x plus 5. 2 goes up here. So now we can say that 3x will be equal to 2y minus 5. We just took 5 to the other side, so the plus becomes minus, which further implies that x will be equal to 2y minus 5 divided by 3. Now, since y is equal to f of x, we can conclude that x is equal to f inverse of y. So therefore, f inverse of y is 2y minus 5 divided by 3. So since f inverse of y is 2y minus 5 by 3, we can conclude that f inverse of x will also be like similar. So it will be 2x minus 5 divided by 3. So basically, we put the value of x instead of y. It's the same inverse function. So f inverse of x, when f of x is 3x plus 5 by 2, is 2x minus 5 divided by 3. Now we move on to our last question. State whether the function f between natural numbers, which is defined between natural numbers, so its domain is of natural numbers and the range is the set of natural numbers, are given by the function f of x is equal to 5x, and we are to find whether it's injective, surjective, or both. So for a function to be injective, it has to be 1, 1. For a function to be surjective, it has to be on 2. And for a bijective function, it has to be both 1, 1 and on 2. So that function is known as bijective. Let's look at our function. F of x is equal to 5x. Now we'll assume two functions, f of x1 and f of x2 as equal. So f of x1 is equal to f of x2. So on putting the values, we'll get 5x1 is equal to 5x2. So on dividing by 5, we'll get x1 is equal to x2. So when f of x1 is equal to f of x2, implies that x1 is equal to x2. The function f of x is 1, 1. So that means f of x is injective. Now let's look at whether f of x is equal to 5x is surjective or not. So for any value x is equal to n, the range of f of x is equal to 5n, where n belongs to natural numbers. And this makes sense. So suppose we put it as 1. So if x is equal to 1, then f of 1 will be 5 into 1, which is 5. And f of 2 will be 5 into 2, which is 10. So it's basically multiples of 5. So the range only contains multiples of 5. But our codomain is the set of all natural numbers. That includes both the multiples of 5 and numbers which are not multiples of 5. So over here, what happens is that our range is not equal to the codomain due to the existence of values in the codomain which are not multiples of 5. So due to that, fx is not an onto function. So therefore, f of x is not surjective. So the right answer is that f of x is injective only. F is only an injective function. It is only a 1-1 function and it's not an onto function. So since f is not onto, it is also not a bijective function. So f of x is just a 1-1 function. That concludes this episode of Cbse board exams. We'll be back with more interesting episodes of more questions right here at Brain Blitz Audios. Over at Brain Blitz Audios, we're dedicated to providing free educational content to all. To be a part of our journey, please subscribe to our channel. So we'll be back with more useful content such as learner words, stories, mind maps, etc. Until then, take care, stay safe, ta-ta for now.